Okay, everyone, if we can get started. Thanks, class. Thank you. So just as a general introduction, the exam overall was quite achievable for a lot of students. I can't tell you the percentage because I don't know it, but the average. But we know that more than 50% of the cohort, of the cohort, I can't talk percentages. Of the cohort, this one, okay.
That's right, yeah, put me in front of you.
Anyone not awake?
Did you
Yeah,
see
you're
that?
awake
She
now.
put me in front of
Is
her.
that better? Yeah. Most of the cohort got 50% or higher. There you are, said it. So, quite an achievable exam. Having said that, Deanna referred to the subject comments, and talking to the converted here, please read them. The SATs and the exam and the investigation, there are really good comments in there. In the exam, because we're focusing on that at the moment, there are comments about every single question and part, about what students did well, what a lot of students did incorrectly. So please get in there and read that. I know some people do some cutting and pasting and actually show it to their students, and you can see them sitting in the class going, well, what was wrong with that? And then you tell them what was wrong with it. So the usual thing, two major things from my point of view, and if you two have something else, then please tell me. Notation, shocking, really, really bad. It's not the place to hit it in an exam. It is your job to get it right in school assignments, tests, you're teaching. So, for instance, I'm talking about integral symbols with a chunk of maths and no dx or dt or anything. That's notation. I'm talking about vector notation. So a dot a, we still see a squared. So yeah, my thoughts exactly. So please really reinforce that. If you have new teachers to school who are new to teaching, who are taking this subject, or you are mentoring them, show them the teacher comments, the examiner's comments. Make sure that they're aware of this sort of stuff. Some people are thrown into teaching this without much background, and we need to help them as much as we can. Anything from you two that you noticed?
No, yeah, brackets comes in later.
Oh, brackets comes in later. With maths, you know, it's a logical sequence of explanations. If you have something like 2x plus 3, take bracket x plus 1, beautiful. If the students miss out that bracket around the x plus 1, but their next line assumes that it was there, that is not a logical progression. You need to mark that wrong at school. We are marking it incorrect in exams because it is not logically fluent mathematics. And I can see lots of nodding, so I hope that means you're agreeing with me and not nodding off.
Yes.
All right, so are we ready to go into the exam? You have a set of solutions there.
You ready?
They have, yeah. So question 1, quite a successfully achievable question with the mean score above 65%. So a lot of students achieved more than 3 out of 5 for that question. Generally, they got those scores in Part A. So when they're doing a show that style question, we are really trying to train them to actually go into that bottom part that Val's circling and actually do a check and say, yeah, I know it's on the line or the point of intersection. I know it's there. So if they're just doing t equals -1, if they're just doing the stuff that is bracketed, yes, all good. But good teaching, good maths is therefore a 044, was it? Checks. just nice. It's nice to have that statement. The next part, we found some students, unfortunately, not reading the question properly. Find the equation of the plane. Some of them tried to find another line for us. One thing I tell my students, and again, I apologise to talking to people who have been teaching for a long time, I tell my students that if you're going to make a silly mistake in the exam, probably question 1. So, because you're rushing, you're in a new room, it's a new experience possibly for you. So get them either underlining words, highlighting words, circling words, to help them through those sorts of questions. Okay, question 2 was very well done again. More than 70% was the mean for this question. That means the mean was a little bit over 5 out of 7. Very, very well done. This is a classic example, if you could scroll up to show B as well. Show B as well, scroll down to show B as well.
Scroll up, yeah.
Yeah. So part A and part B, part I, they are really good examples of routine questions. You know, the performance standards, we need to balance our routine and complex questions. The exam does that. Your SATs need to do that as well. So these two we would classify as routine. The wording in the first part, find the exact, is very important. Again, it's one of those words that I would say, circle that word, watch out, don't trip over it, do it. Basically, do as you're told, clean your room.
Yes.
Show that. You would all know by now that we do not give a mark for the statement that they have to achieve there, the theta equals arc tan x on 50. We're looking for the working to get there. And again, very, very basic. What's that, year 9? Very basic. So a lot of people would have got 2 marks there. B part 2 is where people fell down a little bit. But you see the working there that Val's put together is not assuming a generalised formula for the derivative of arc tan x on A, let's call it, x on A. And that's because we're the age we are. But I really think that we should be teaching students for understanding and not necessarily learn the formula, find it on your on your note sheet. Why shouldn't they show us each one of those steps to get to the third line? Obviously is not the mark. So again, that's something that I would be reinforcing with students. Do the work for understanding. Try not to just grab a formula and throw it together, because you can fall in a hole with that if things look slightly differently to you, to the student, being the you. In the part C, where students fell down was the putting together of the dx dt. So in the second line there, where Val's got when t equals 9, dx dt is. Some students did not connect that with the previous parts of the question. And another part that we need to make sure that they're reading is answer correct to 3 significant figures. In the specialist exam, there will always be, as far as we know, a section where we test their rounding. So if a question specifically says answer correct to whatever, they've got to do that. This was a tricky one because the 0 and the 0, but not beyond year 12 maths. Don't go on. I was going to say something else. What was I going to say? Question 3, again, another high mean of above 75%. So again, more the mean was 5, a little bit over 5 out of 7 for this question. So again, you should recognise A part 1 and A part 2 as routine. Whether you have a Casio or a TI, it is best if your students can do this by calculator. If they can't, they may be using more time than we would be hoping they do for this 2-mark bit. Very popular question. It is the third most successfully approached in the exam, this question. B part 1, so with the diagram there, that comes in a bit later, write Z2 on Z1 in polar form. So again, it's 1 mark, so it can be just gone bank onto the calculator, or you could use the fact that you've done the polar form in A part 1 and 2 and use that. Now B part 2 is where some students tripped up. When we're talking about the value of theta and we want an exact value, we need students to recognise the size of the angle down to Z2, the size of the angle down to Z1, and their difference is pi on 6. Is that all right, making sense? Yep, so can you put the diagram back up for me? So here I'll yell, teacher voice. Evan. So you should know that angle there. You should know that angle there. Obviously, that's how you work out the pi on 6. Part C, some found this tricky because we're not expecting theta to be negative pi on 6 because we have got a size there. Theta is the angle between Z2 and Z1, so it is actually pi on 6, not negative. So we've simply got the modulus of Z3 to work out for the polar, to use in the polar form is, where is it? Up there. Where's it gone? Oh, you're told that it's a factor of a half, so we know that it's half times 6 is 3, and the angle shown in the diagram there, and Val's got the working there as well. The theta is the pi on 6 with the 3 on 2. That's where the theta is used. So things to notice in those first 3 questions are, for your assistance with your SATs, is notice the routine, notice the complex. Look at the balance in those 3 questions. And also the use of exact, the use of show that, and the use of, in this particular case, it came up, the rounding to a particular degree of accuracy. Is there any questions on 1, 2 and 3?
I have a question.
Yep, sure.
How do you deal with carried marks? Let's say they stuff up on theta.
Yep.
And they use it below. Do they still provide a question change? How did you carry marks down from B to C?
Just a sec.
So let's say they
So
got
that would
that
be-
wrong.
Sorry?
Let's say they got that wrong, but they've got to use it in the next question.
Yep. That would be follow through.
It's just plain on follow through.
Yes. I think we...
What if they had it as a negative number?
Yes, that's where they would lose the mark.
Yeah.
Yeah. Any other questions? Yeah.
So, but I have a question where it's done it by hand, so it can calculate it. Just like that, square root 12.
Fine.
That's fine.
Yep, that's fine. And in B part I, if they had the root 3 as, what would that be? 3 on root 3? Is that right? The other one?
Yeah, good.
Yes,
Yeah, that.
root 3.
3 on root 3, if they had that. Yeah, that'd be fine. All right. Over to Val. Hello, Wizzy. Big voice, Val.
No worries. Right, now we're on to induction. Right,
Too
don't
close.
get too close. Okay, got that. The mean for this question was around 64%, so it wasn't too bad. So the kids have done reasonably well, probably not so good at part B. But some of the things that you have to note, and we have said this before, but we'll go again, it doesn't state a proposition at the beginning. it says prove whatever. So the first thing you've got to do is define your proposition. So that's why we've got P of n, 4 to the n plus 15n, blah, 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 divisible by 9, etc. You don't have to use NEZ. They can write in their language. I've just written that because I can't with stuff writing all the words. All right, but they have to write the proposition. And they must also have that closing statement with it. If they only have that closing statement and not the proposition, they haven't actually proved anything because they didn't state a proposition. So we need both of those. Now when you're setting out, they check what the starting value is, and in your SATs, it's a good idea if one of your induction questions does not start at 1, because they might get one that starts at 0 or 2 or 3 or whatever. They do have to notice where it's starting at. This one said positive integers, so obviously it's at 1. And there should be some working there, not just saying, yeah, it's divisible by 9. They should provide some working, so as I've done there, that's fine. And now the next bit.
Sorry, I'm used to a Mac.
Next part where they assume or suppose P of K is true. They write their statement. Now, they don't have to write equals 9a. This is the way we see most of the students present their work, and that's why I've done it like that. So they could say is divisible by 9, but if they do this 9a, it's really important that they say a is an integer, because 9 times 1.5 doesn't make it divisible by 9, does it? So that needs to be stressed in your SATs. That's where you really ping them. Obviously not in every question if you gave them a lot of divisibility, but you would ping them so they know they must understand why it has to be an integer. Then we go on and consider P of K at 1. I've set it out in the way that I said most of the students tend to do their workings. So we put in the K at 1, etc. On the third line, the 4 brackets 9a, it is nice to acknowledge where you've kicked in with your PK statement, because that's how induction works. You're going to use that P of K. And basically you just do all the algebra and wash it all out, and second to last line you've got 9 lots of 4a, take 5k plus 2. When I'm teaching my students, I say to them, well, you know a is an integer, so 4a is an integer, you know k is an integer, you've multiplied by 5, you've added 2. Obviously working with all those integers, you're going to have 9 times another integer. A lot of people will just say after that second to last line, which is clearly divisible by 9. That's fine too. I just like to sort of make it succinct and just say it's 9b, where b is an integer. And therefore P of K at 1 is true. And then your statement, like the ladder or whatever analogy you use, since the first statement's true, P of 1, and P of K at 1 is true when PK is true, then by principle of mathematical induction, P of n is true for all n in Z+. So, and another thing, you should not be awarding that mark for the last statement and the first one if they've done nothing in the middle. They don't deserve that final mark if they haven't actually done much other than P of 1 and assume this and write this, but not do the guts. So we call it no guts, no glory. So they need to have that middle part to get that last mark. Right, now you go on to part B, and I always tell my kids, look at what part A says. And it says, using the result of part A. I don't know how much simpler we can make that statement. It says, show that what we've got there is divisible by 3. They should immediately go, 3, not 9. Okay, note to self. And then they've got their statement, and again, they're trying to get PK happening in there. There are different ways of setting this out. Some people would go, if it's 4 to the n, add 1, let's have 4 of the whole lot of PK and play with it that way, and that's fine. I've just got one variation here where, again, I've used the 4 to the n back from PK there, is 9a, take 15, n plus 1. I noted to myself over there, it would have been nice if I'd said that n is an integer, all right? I noticed that afterwards.
A. A is an integer.
Oh, yeah. A is an integer, sorry. N is assumed to be an integer, yep. So therefore, it comes out and you can see you get a factor of 3. Yes?
Wait, please.
That's okay. I'm done.
I'm just wanting to clarify if Sir still thinks that it's true that there are better ways to test trig identity knowledge than either PMI and learning center.
Never heard that.
Yeah, we've never heard that one.
Never heard it.
So what he said 2 years ago.
Probably
Can we expect trig and PMI to be combined in an exam?
It's a possibility because it's written in the curriculum statement, and can I also point out that last year calculus was included as well, so the idea of DDX of whatever, there are other ones that you can investigate. I know I actually did do a calculus one in my test because I managed to find one that the kids that are doing, some have done methods but most of them haven't, and so I found one that they could actually tackle at this time of the year. But you would certainly revisit later on. And yeah, with trig, I mean, when I set them in my SATs, I give them a leg up. I'll have an A part 1, show so-and-so, part 2, show this. And obviously in the induction proof that follows, they're going to use that. I've set them up ready for success, not blown them away with. I know some of them, the P of 1 is very hard if you're doing the ones in the hazy text.
Can I just go there?
Also, the trigonometry can come into a lot of the parametric stuff where we do lengths of the length of path and also the speed. So we're using trig identities there as well.
And anything on that formula sheet, you know how they often, in Year 11, they probably do duplication, addition formulae, but they don't do as much of the others. But I've always made my students aware of the others and said these are other formulae and they may crop up the way you turn a sum into a product or a product back into a sum. And so they should be familiar with what's on that formula sheet and know that it could be used. So, okay. No more questions about induction? And, just one more thing before I answer your question. We actually suggest with induction with your SATs, that's a really good place to do your conjecture and proof, provided you have a conjecture that's going to be pretty obvious. And matrices is a nice place to do it. And if some of the elements are hard to work out, I'll just tell them, one or whatever, and get them to fill in the other ones. So you don't want them to not have success at going on, but it's a really good place to do it because it's different to methods, in the way that we do it. And that way you've got that box ticked and you can move on. Because it's not a good thing to do in investigations because you tend to all have the same result.
Yeah.
Yes.
Just to clarify, 5 marks induction with competition and one of the states where it's that's correct. On mark the state there.
Depends on the difficulty, really.
Yeah.
So there's one for the PN statement and the final, yes. But the guts in the middle can boost it out to 6 or...
Yeah. The statements, wide marks might be best. Which you better give wide mark there. So yeah, the 5 statement, that's all.
Yes.
Yeah, that's the way it goes.
Yep.
Other marks, one for big one for the student, okay?
Yep.
And there might be 2 marks for proving okay plus mark.
Yep.
Yeah.
Yeah, depending on complexity.
There was a question over there.
Is there a question over here somewhere?
It's what the statement won't be true because we're often with further induction, some statement is not true.
I can't hear.
Sorry, please say it again.
The starting date is not always fun, so sometimes you put it with P up to.
Yes, that's right. Yep.
Good. Right, we could get that. That's good.
You got
He was just talking about you'd get a mark for P of 2 if it started at 2. It's just for your starting value.
That there.
Good.
This one was starting, it said positive integers, so it started at 1. But if your proposition was going from 2 and above, then that mark would be assigned for showing that P of 2 worked.
Okay.
Good.
Okay, this next one. This was a pretty well done question. They were averaging around 5 to 6 out of 9, which is pretty good. And the weaker part of it was really the geometry. So I'll start up here, augmented matrix. Hopefully they can all get that right. But there were some students, when the A's got in there, they were including Z's sometimes, so a bit odd. But generally speaking, most kids are going to get that right. Now, what we must see, it says using clearly defined row operations. Show that. So there's two things. So row 1 take row 2 is what's been done here to get the new row 2. That's fine. The algebra is fairly simple, so probably wouldn't expect to see any working. Besides, no, that line's given, yeah. So as long as that row operation is there, you'll be fine. But the next one, we found a lot of students were doing, we've got row 1 take row 3, and we get that result there. And then when you go to the next one, and again, I think at that stage, your 3 row 1 take row 3 is still fairly simple to work out. But you'll notice in red, I've got the working for when we've done, okay, your final new row 3, it's written as 2 row 3 plus A take 3 row 2. A lot of students, as I teach mine, that subtraction is always that take that, so I always make them do so many of that one take that one, just to avoid carelessness. So I actually set it out a bit differently, and some of the kids did. They did 3 take A, looking at the original block of matrix thingy there. They would have done 3 take A by row 2, take 2 row 3. But the issue was that comes out as negative what the result is, and some of them just went, okay, let's hope they don't notice. But we did notice, and if they do that and they don't get exactly the same, they have to do an extra bit and explain that they're going to times by -1 or divide by -1. So that was one of the biggest things we noticed there. But when it is more complicated like that, we would expect to see some sort of working. Yes, they've got to say their row operations, but it's to show that. And when it's more complex like that one was, we'd expect to see something. Right, this next bit, the geometric interpretation. This is about whether you're getting a line, a point, plane, whatever it is. So it's not about the number of solutions. So the students seem to be a little bit confused. Clearly that first picture shows there's no intersection and none of the planes are parallel, etc. So you just look at your row ops and you can see that if A is 7, I tell them I don't like them rote learning that. If A is 7, it's telling you 0x, 0y, 0z equals something that is not 7, and that does not make sense, therefore you can't get an answer. So they shouldn't be rote learning, they should be thinking logically what it is saying. So the answer is simply A is 7. And make sure they answer correctly what value of A corresponds to that, not what, sometimes they've said it can't be this number, instead of saying it is 7. You know what I mean, don't you? Yeah. Next one, interpret the geometric solution for the case A equals 3. I think it's a good idea to write the matrix with that value put in, and you can see that the last line is going to lead to a value of Z. The second to last line of the matrix is going to give you Y, and clearly you go back there and you get X. A lot of students wrote the coordinates of a point. The actual question says interpret the geometric solution. We're talking about the fact that they intersect at a point. So that's the reason point is underlined. That was what was required, just to say that it's a point. But good working would be they'd probably do that matrix and make that decision based on it. Next one, state the value of A for which the intersection is a line. So if you wrote A equals -1, you're good to go. Again, the bottom row is a bunch of zeros, which is telling you 0x, 0y, 0z equals 0, and you go, oh, geez, anything. So you're thinking, well, anything within reason. So you're thinking there's an infinite set of solutions. So logically, that's your value. And last one, find the equation of this line for the value of A found in part D. So I've just got the matrix written there. I've gone with let Z equal T. Clearly, you could do let Y equal T, and you could argue your values through, and that was always looked at if they did that. This is just one presentation of the answers. Now, before Dennis steps up, is there any questions?
The 2023 paper was a good preparation for these kids for future life. What is more important as an adult is having a happy hour. At the end of the day, when all the work is done, when you listen to the principal say the same thing for the 23rd time and you've read all the data, the happy hour is the most important thing. Well, for our students, they had a happy hour. Paper 1, book 1 was their happy hour. The kids did so well. Questions 1 to 5, they were sitting on about 70%. We can't give exact figures, but about 70%. It could have been 69, it could have been 71. But about 70% was the score, was the mean score for questions 1 to 5. That's excitement, but the kids kind of expected that because part of their teaching regime was to have a look at past papers. Normally, questions 6 and 7, the sword of Damocles falls down on them. But questions 6 and 7, it was the happy part of the happy hour. Questions 6 and 7 were the most popular questions in the paper. Wow, what was happening? Why did this happen? The mean mark for questions 6 and 7 was very close to 80%. And that occurred because kids were heeding the instructions of teachers. What, my God, is happening in this bizarro world? Students listening to teachers, they're actually showing they're working. They're being tied in algebra. They're really doing the right thing. And boy, paper 1 was the happy paper. It was the happiest paper in about 30 years. Question 6, the beauty of calculus, solving differential equations, slope fields, logistic equations, all this new age mathematics that a lot of us, though I'm looking at the audience and there's a lot of youngies here, a lot of us of the old school, we wouldn't have had that in our regime of calculus. We would have done first principles, and then when we finished first principles, we had more first principles, and we had trig first principles. Boy, they were happy days. Remember finding the derivative of tan 2x from first principles? Wouldn't that be a great question? We could maybe give it as an inductive argument. Whatever is inductive argument, you don't want to know about that. But question 6, the beauty of New Age calculus. The mean mark for that question was about 76%. The beauty about that question was over 40% of the students got it fully correct. Wow, good calculus. And at the other end, there were only about 25 respondents out of about 1,200 that couldn't score a mark in that paper. So that was really good. It's popular. Calculus certainly is king. There's vectors and there's complex numbers, but calculus really gets a Guernsey. The first question, a nice bit of algebra. When the new course came in 8 years ago, not a common response, but about 20% of kids would have said, oh, yeah, that's okay, I got that on my reference sheet, but instead of having a B, I might have had a P, and that was their proof. Okay, the times have changed. I think we only came across 2 of that 1,150 kids who actually wrote down that thing, and they obviously did it as a joke. All right, so they showed their algebra. And then solving the logistic equation using integration techniques. We don't want them to do it the methods way by doing the derivative, all these funny, cute little things that they do in methods. We wanted them to show some integration. And by golly gee, there is some good stuff there. It didn't even fit on the space that we left them. We had to overflow. But you could feel the joy coming out of the kids. They were putting in modulus signs. They were doing correct algebra. And most kids got that fully correct. And you might argue, oh, is this really good for an exam? Everyone knew it was going to be in, but I think it's terrific. This is what we wanted the kids to come away with. So that part was really well done. And we used to have trouble with kids not putting in modulus signs, and because the answer was given, they sort of fudged it. Not too much fudging anymore. Really terrific. That was an excellent response. The slope fields question, we used to have a little bit of trouble of them not knowing where to start, so we started it for them. It wasn't that good. The price they paid for that, instead of the slope field question being worth 3, it was actually only worth 2. But that didn't stop them. You don't cross field lines, and it asymptotically approaches 600. Once again, really well done. The kids enjoy these slope fields questions. And once again, a lot of us mightn't have come across this stuff in our little regime of mathematical journey. The next bit, putting a spin on it, and it caught a few kids out because they were looking at the graph which had an asymptote at 600, and I guess in the joy of going on in the question, they missed the fact that this new little population of butterflies could peak at 960. So some kids put k equals 600, they lost their mark for that, and they could get a mark for finding the value of A equivalent to the 600, but they couldn't progress very much further. So, and it's fine to say, oh, make sure you read questions, but you can understand the angst of students. So a few kids got caught in that, and I certainly would hope that it wasn't a matter of entrapment by those who said it, but those who did it, the 960 was well done, solving it to get A equals 7, and then you could either graph the thing or solve it using your calculator. We would have accepted 24.6, we would have accepted 24, we would have accepted 25. But that question 6 was a magnificently attempted question. Really well done. Almost the most popular question in the paper. And it's really, really good mathematics. I mean, these kids who do this type of logistics stuff, in 60 years' time, or is it 600 years' time, they could be building nuclear submarines. How good is that? I think we're going to get submarines somewhere along the line, but I don't know if that's where we want them to go. Question 7, even more calculus. The real good stuff, the stuff that only appeared 8 years ago, the real calculus. This is the calculus that some of us, not too many of us, would have done at university. Integration by parts, volumes of revolution. Wow, high-powered stuff. The technology involved in doing this is so applicable. Question 7, the most popular question in the paper, had a mean score of 80%. Almost 40% of kids got full marks for it. And the beauty of it, only 17 poor little souls, light a penny candle for them, only 17 poor little souls didn't even score a mark in that question. But that was certainly the most popular question in the paper. And it was kind of good stuff, the integration by parts. It was well set up. Some actually attacked it by having one function as x and the other function as xex, and they sort of took the prompt the other way, but bless them, they got to the answer. And once again, there was good working shown. The reason why kids did so well at that is that they heeded the advice of the teachers or the chief examiner or whatever the person is called, and they showed some good algebra. Really nice stuff. And I got to take my hat off to that. Integration by parts. If you can do integration by parts, you ain't some poor sod doing methods. You're a mathematician doing specialist. Rah, rah, rah. Okay, and the next bit, and whilst the average student is well rewarded, we've been told in the past you've got to show all working, you can't just write down the answer. I've got to show that I've got to take the square root of that thing. And I guess the poor markers were instructed, we got to see them talking about the square root of 1/4 being equal to 1/2. That was the little key to getting that 1 mark. And the beauty of so many average kids, whatever average means if you're doing specialists, you're superb if you're doing specialists, but so many kids with an average type of score picked up that mark, whereas 5 or 6 years ago they would have said, isn't that common knowledge? And the only sad thing a little bit is some of the very, 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 very good kids would sort of look at that and say, isn't it obvious? And maybe instead of getting 100 for the paper, they might have got 99 and 98. But that's, I mean, if they're very good kids, they will heed instructions. But hey, we're all very good. Do we always heed instructions? I mean, you know, you come back and the principal tells you stuff and you say, what did he or she say? Nah, doesn't matter. Next bit. Nice use of your graphic calculator technology comes in. Be accurate in drawing it. We're sort of looking for the shape, the beginning, the end, and maybe some key feature. And I think the markers were asked to address the fact that it goes through the 0.01. Okay, so, but that was a use of technology, kind of an easy 3 marks, so you can kind of see why they've done well in that. The next bit, same as showing the square root sign. It says on the reference sheet, the volume of revolution is pi, the integral of y squared dx. They put in y squared dx. We actually wanted to see the half square root yada, 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 all squared. And once again, that's what your average kid did. They picked up that easy mark. Maybe some of our very top stars, not many, would have said, this is obvious, this is the answer. But you've got to show you're working, all right? You've got to pay a little bit of price for the joy of this happy paper. Okay, so we all know to have happy times, you pay for it. Is marriage an example of that or not? Okay, anyway, too much. And the last bit, to show the volume of revolution, you use the hint. Some people actually wanted to do integration by parts again and used the 4 take x squared as a function instead of expanding it all out. Bless them, they did some nice integration by parts again. Perhaps like me, they just loved integration by parts. Perhaps they just spent 20 minutes doing integration by parts because it was a cool thing to do. And once again, it's easy to fudge because you've got an answer. And I guess in that journey there's really 2 marks for the top 2 lines. That last mark is for some quite hard yards of doing the next 4 lines to get that final answer. But once again, the most popular question in the paper, the most well-attended question. If we actually went in the exam room, the smiles would have been beaming on their faces. Boy, this specialist exam isn't too bad. What have the kids been saying in the past? Well, we've got 15 minutes. 15 minutes, okay. We come to book 2. Book 2 is where the crunch comes. The vectors, the normal things, cross products, yada, yada, yada. An interesting aside, and I must quickly, in this question, only 40 kids didn't score a mark. In the first question in the paper, which was a vectors question, 140 kids didn't score a mark. So did they become smarter by doing the exam? Did they get less nervous? I think they were less nervous. The first part was quite well done. Some kids started the other way, but that was well done. Up we go. The valuation of a vector, how easy is that? Working out the vector AB, I think that working out the vector BA, that's where you obviously can get your mark. Everyone's got to get that. Pushing on, finding the cross product, your graphic calculator will do it. Interestingly, quite a few kids missed finding the modulus of the cross product. They actually just found the cross product, but the knights in shiny armour, who were their markers, if they did it in the part 2, that mark flowed back. So that came back. Part 2 was well done. Part 3, finding the equation was quite well done. Part 4, t equals 2. Once again, in the old days, they would have said, oh, yeah, if t equals 2, the yada yada, the other bit is true, but they actually had to show that computation, or putting in t equals 2 for x, y, and z, but they did it. So they picked up good marks. And for those two parts, the most common score was 11 out of 15 for that paper, because the crunch came, and this is the crunch of paper 2, yada yada. Only about 10% of kids got any marks in this. And it was really quite straightforward, we can say standing here. Using similar triangles, one bit is 5 times the other bit. We can find a vector AC, we can find C, and we can just plug it into the equation of the plane and find the unknown K. The beauty about being a marker and seeing these exams, especially specialist, some of these students, as you would gather, are some outstanding students. And there were other ways of doing it. Some found the intersection of 2 lines, the normal and the AB line. Others used distances from points to planes to do it. So there were other ways of doing it, but that last part certainly kept the kids out. It was the most popular question in the second paper. It had a mean score of about 60%, but only 90 kids got full marks for it. So what's happening? Are they heading in towards the abyss? We will find out in a moment.
Yeah, they seem to have a preconceived idea about complex numbers. Okay, so question 9.
Got it? Yes.
Right, they see complex numbers, and I think some of them just freeze up. This, unfortunately, had the lowest score across the whole exam. The average was only around 6 out of 15, so not good. The first one should be quite straightforward. Write the zeros of z to the 5th equals 1, z to the 5th take 1, sorry. So they just go through a process and they'll get the answers. They don't have to do the conjugates. I personally teach doing the conjugates just to encourage their visual geometry of conjugate pairs, because that may come up in a question, but it's fine to do 6 pi and 5 and 8 pi and 5 for those last two. And it says using Demoivre's theorems, so they shouldn't just be stating the answers, they should be showing how they've used it. Okay? Right, next one. This was really poorly answered. In the syllabus or the curriculum statement, it does mention that from the triangle inequality you get the generalised result that says if you had the, for example in this, the mod of Z1 plus Z2 plus through to Zn is less than or equal to the mod of Z1 plus the mod of Z2, you can do an induction proof for it. So that seemed, it was very poorly answered. Very few kids got that correct. So they needed to say that it was less than or equal to the mod of each part, and then the mod of each part was 1, and therefore you get a total of 5. For part 2, they were good at going, yep, I reckon 1 works, and so they got their mark, so that was fine. Now, see part 1. When they've done the multiplication, they need to very clearly show they're working. I've gone for the easiest bit where you just do z squared by z, take 1 first up, and I've set it out like I've encouraged my kids to do, where as they're expanding, because they tend to go that, etc. And I tell them, if you line them up in the columns, then they don't make the mistake of sort of when their eyes jump, reading the wrong coefficient. So that's just a suggestion, that's why I've set it out that way. But they should get z to the 5th, take 1. That should be an easy 2 marks for anybody doing specialist. And in part 2, there were too many kids who thought they'd still give all 5, and they did not exclude the 1. And so if they did not exclude it, they can't score that mark. They're not allowed to have extras, they've got to have the correct 4 to get that mark. Now going on to D part 1. This was well answered by the students who did it. And if it says it's showing it's real, it's kind of implying that you need to go to Cartesian form to establish that. If you think about it, if you've got to show that it's real, then there's no imaginary part. And that's what I would encourage kids to think about. Because when you work with complex numbers, you're either in polar form or you're in Cartesian form. And the makeup of what the question asks you should direct you as to what you should do. So when you flow it through, it is nice. I tell my kids that when they do cis of negative theta is cos take I sine, it's nice to acknowledge cos of negative theta is cos theta, sine of negative theta is negative sine theta. We really love that when we see it because we know they're actually understanding what they're doing. It's not written on here. I'm just saying that is good practice in your teaching. And you get that answer there, which is real. Some of them went all the way through and got the result in part 2 straight up. That's fine. They scored their marks there. And again, they're led through. Once you've got 2 theta and you know you're only looking for theta, you grab your formula sheet, unless you know them off by heart, and you look for something that changes a 2 theta down to a theta and only deals with cosines. So sometimes we also saw working in part 2 that was allowed back in part 1 because we look for them doing the correct things. And in part 3, they were pretty good at using their calculator to get negative 1.25 for the kids who pursued it, but it was the very last part that they seemed to miss. When they did it on their calculator in part 3, if they look at their quadratic from the one before, when you do negative b over 2a, you get negative 2 over 8, which is negative a quarter. So therefore, you're looking for cosine of theta to be negative a quarter. So on that picture down here, see how those positions are the negative a quarter for cosine of theta, which is your x value. And that was the easy way to draw it. And that was really poorly answered. You do not have to draw in the lines from the origin. We just tend to do that. It's the dots up the top and down the bottom which scored the mark. So I'm just saying it's easy to find their positions because their x values would be negative a quarter. Do you want to ask anything before Deb finishes up with the last one? Wes?
As I say, outside of guidance, obviously control thoughts about A part or part 1, they could have looked for those apart instead of where it says show the N Z is that, just meant use that and it said yes, it's real.
If they didn't justify, it says show that it's real. If they have not justified it, they can't get credit for that because they haven't shown anything using something that's given past. Unless they justify that 4 cos squared plus 2 cos take 1. Unfortunately, no. They haven't shown anything. Except they tried to be sneaky. So, nothing? Okay, your turn, Constance.
Okay, question 10. Around 57% was the mean. What do we got? We got 4 minutes. So, right. The average was over half marks for this out of 15. So showing that, the cos squared. Now, in the papers in the past, we see that it says using integration by parts if it is an integration by parts. So heads up, try not doing it by integration by parts. So if you're looking for a sine 2x on the right-hand side, then there was probably a cos 2x involved in the integral. That's the sort of logic that I would be trying to get across to students. 2 marks for that. We needed to see the half sine 2x on 2 for their full marks there. Part B, 3 marks usually for a curve, and we would be looking for the domain, the range and the shape. So the domain, the range and the shape. Students are tending to draw these in a better way recently. when they were first in, gosh knows when, we used to just get that. That'll do. I'm in a rush. But I know Val and I have run sessions on how to actually get some points on there, give it a bit of time. My definition is 3 points per curve to help you draw something quite nice. So moving on to the next part, this was written into the, is it right?
Yeah, I'm just showing the picture first.
We did mention in the subject outline, it does go to 3 components now. So we would never ask students to draw a 3D curve. So that sort of graph that we've got there for the flight path with the X, Y, Z axes, we would never expect students to draw on that. Thank goodness, because I wouldn't want to mark it. All right, so see part I, very generous marking here, 3 marks. One of the marks is to actually find that dz dt is 4. So, should have at least got 1 for that. C part 2 is where a lot of students did struggle, and we did see a lot of imaginative style mathematics there without the use of complex numbers, just that it was imaginative. So the key to that is to find the perfect square that is in the third from the bottom line. There are different approaches. This is one way that we saw commonly approached. We did see lots of different other ways that were correct as well. So 4 marks there. Obviously, we would give a mark for the setup, not for the last line, but 3 marks worth of algebra manipulation. Hence, big word in the maths questions means you must use what you've just done. And when you're asked for an exact solution here, we do need to see the third line down with the substitution of 3 pi on 4 in and the pi on 4. We need to see either that line or the next line, something in there that tells us that you're actually doing the integral. And that makes me remember what I wanted to say right back in question 1, 2 and 3. In specialist maths, the questions, if they have parts to them, they are related. And don't forget what you've done. So sometimes, generously, the question says, using part A, just do it, use it. But sometimes it says, hence show. Sometimes there'll be stuff from way before, and the students need to be aware of that in specialist. If you've done part A, I say to my students, if you've done part A, you've done it for a reason. And when they are questioning me in class saying, well, how did you know how to do that? I would say, look at part A, and they went, oh God, we did it for a reason. So with specialists, definitely. In methods, that doesn't always hold true when you've got the first lot of questions there, differentiate or show that or whatever. So that's it, and we have gone 1 minute over time. It's Deanna's fault.
Go to our next one now.
Yeah. So Val and I will be heading into another session. If you are attending that, you can ask us questions, and we'll answer Dennis's questions as well, if you like.
Dennis here to answer.
We can leave Dennis here to answer the lot. Thank you.